Good morning, everyone. I am Speaker Vincent Liang, and my topic of the report today is potential interaction between plastic litter and green turtle Chelonia mydas during nesting in an extremely polluted beach. And this is Chelonia mydas, and this species will be focus of my report. And Chelonia mydas is a kind of green sea turtle. Then I will talk about the purpose of these studies. The first point is determine the composition and amount of plastic on green sea turtle tracks. And the second point is assess how much these plastics vary between different beach zones based on whether green sea turtle can lay eggs or not. And the last point is determine the potential risks these plastics pose toward green sea turtles. And then I will talk about the material and methods. And the study is on the sandy beach of the Segat coast of Turkey. The Segat coast is right here. And the sampling time is June to August 2018. Why to choose June to August? Because this time period corresponds with the highest nesting activity period of the sea turtles. Then I will talk about the selection of the turtle tracks. There are 4 different types of sampling tracks, and this is case 1. The sampling point 1 is the less high tide line, and the sampling point 2 is the middle of the beach, and the sampling point 3 is the end of the beach. And case 1 is the turtle crawl out of the sea and lay egg, and sampling point you can see that nest with egg. And case 2, you can see that the turtle crawl out of the sea and nest but did not lay any egg. The difference is here, nest without eggs. Case 3, the turtle crawl out of the sea but returned to the sea without digging. And you can see that this is the sampling point 2, but the turtle did not nest and dig in here, just pass by. The case 4, the track belonging to the hatchlings, and these tracks are the crawling tracks of the newborn turtles. And the case 1 to case 3 is for adult turtles. And the plastic sampling, the sampling condition was the wind as the median and the maximum wind speed only can 2 knots. Then control 2 centimeters of sediment and control larger than 2.5 centimeters of plastics. Why choose larger than 2.5 centimeters of plastic? Because it's visible and turtle will mixing up the sand when they crawl in, eliminate the needed for the sand sieving process. And the plastic sampling will in point 123. The data will use statistical analysis, and the first method is ANOVA. ANOVA is used to test if there were any difference with regard to plastic concentration among landing type, and whether plastic type differ within the total. And the second method will use the Duncan multiple cooperation test. And I will introduce about 7 types of plastics. The first type of plastic is disposable, and the second type is fail type, and third type is fishing related, and the fourth type is foam, 5th type is fragment, and the 6th type is miscellaneous, and the 7th type is textile. And I will talk the plastics later. And this is the result. And this column is 7 types of the plastic, and this row is 4 types of turtle track. And in this one, MISC is miscellaneous, and I will call it. And this one is landing with no nest, and I will call ONT. And this one is hatchling tracks, and I will call LFT. This one is landing with nest but without eggs, and I will call NWOE. And this one is landing with nest and eggs, and I will call NWIE. And the SP1, SP2, and SP3 is the sampling point, and I will call SP. And you can see that the ONT part have the highest concentrations of plastics. And the found type of plastic is the most prevalent plastic in this data. And the next result is according to the Duncan test. We will separate the plastic to 3 groups. The first group is consist of the film type plastics, and the second group is consist of fragment type plastic, and the last group is consist of the other type. And the film type and the fragment type are the most common type found in the sample. And you can see the data, and we give the order of the group like this. And these 4 types of plastic is in the three group. And the next result, we can see the chart, and the x-axis is 4 types of turtle track is ONT, OFT, NWOE, and NWIE. And the y-axis is concentration about the plastic number per meter. And the sampling, blue dot, orange dot, gray dot is the sampling point. And we can see that the difference regarding plastic pollute were only found to be significant for the ONT group in this group. And the result is the highest amount of plastic were found around the nest or the end of the beach, and the next point is the lowest amount was found in the middle area of the beach. And this PCS is the unit is abbreviation of the piece, a type of quantifier. And the next result, and we can see that the first row is plastic group is 7 kinds of plastics, and the second row is category. And this category is show that what plastics will have what liters. And the third row is the plastics total abundance, and is here, and the potential effect is the last row, and the potential effect is show that the plastic what might cause what potential effects. And the results show that the foreign cementage beaches are very problematic and risky nesting area for green sea turtles. And my discussion is the dominant current system in the cementage area is one of the most important reasons for this high concentration of plastics. And the second point is green sea turtle females are philopatric, and they visit the beaches they were born every year to nest. But because of the plastic pollution, so the green sea turtle females appears some choices not to nest on the beach and lay eggs. And my conclusion is a severe plastic pollution in addition to the already existing pressure suggests that they go through a quite difficult reproduction seasons. And then next point is microplastics present in turtle nests significantly affect the ability to hatch and the gender ratio of hatchlings. Thanks for attention.
How do you get your sample? You just collect the surface or you dig?
Repeat.
Say again.
How do you get your sample?
Repeat his question.
He want to know how to get a sample, and the sample was collected on the cementage beach, and the plastic was mentioned, but I didn't put it in the PPT.
So what is the actually influence of the plastic to the turtle, the rate of turtle hatch?
No, what?
What?
The rate.
Rate.
Yeah.
Repeat your question.
Say again.
Oh. How do plastic influence turtle born?
Influence born. The plastics in this paper only show that it influence the female turtles lay egg or not, but not mention will influence the newborn turtle.
Can you go back to your discussion? And next page. And the point two, you say the microplastic present, but in your method, did you measure it?
She want to know. Please say again.
You say microplastic present in turtles. So did you measure it in your methods?
What's the question?
She want to know the microplastics present in the paper. And the 7 types of plastic will, some type of plastic will be break down to the microplastics. So, but I didn't tell it to. I didn't mention it to. But I didn't mention it, so I. So I. Did. So I. So I didn't put it on the paper. Yeah.
Did you measure microplastic? Microplastic, not plastic. Microplastic.
Oh, I didn't mention it, but the paper has said the plastic will break down to microplastics, but I didn't put it on the paper.
Can you explain why you only choose green turtle in your study instead of other kind of sea turtles?
Repeat his question.
He want to know why I choose this Chelonia mydas, but not other green sea turtle. I choose this species because just look on the internet, but the paper is on the upside, so I choose it.
You mentioned about turtle will misunderstand the brand with microplastic. So what will happen or influence if the turtlenecks have microplastic?
Please again.
What will happen if turtlenecks have microplastic?
She want to know what might happen if they have microplastic. The female turtles will choose not to lay egg in the plastic pollution too serious place. So maybe the beaches is pollute too severe, and then the female will not choose to lay egg on there. So the female turtle will lay egg in some not have pollution place.
So you mentioned 7 groups of plastic, and what is the point of pointing these 7 groups out? Is it like different effects or something?
Please again.
So you mentioned 7 groups of plastic,
Yeah.
right? And what is the point of mention it? And is it like will have different effects?
What's his question?
He want to know what 7 group of plastic or different may cause different effect.
Like why do you separate it into 7 groups?
Why? Oh, he want to know what separate the 7 plastics. Group.
Yeah, sure.
Uh, these 7 type of plastic is separate by the paper, but they didn't mention how to separate the 7 plastics.
All right, you didn't answer his question.
What is Duncan multiple test?
It's a kind of, he want to know what is Duncan multiple comparison test. This Duncan test is the kind of statistical analysis, but I didn't study this class, so I can't tell you what is it. Just it's a method to use to analyze the data.
So regarding Vincent's talk, so at the beginning he had a very clear, where is it? Purpose slides. So we know what he wanted to achieve, and then, however, I figured out that his slides is a little bit poor in images. You did not use that many images. However, actually, there are many places where you can add images to make your slides more interesting. For example, these are the chart from the figure, and then you talk about plastic sampling, especially those different types of plastic. Actually, these plastics, they are in our daily life. So if you want to give stronger impression to the audience, what kind of plastic people dispose on beach are more likely to influence the behavior of sea turtles. You should ideally use images instead of these long texts. It gives less impression. So use images. And then here it's nice to see that I think you make this table yourself, right? So which is quite nice. And then you talk about these abbreviations. I know they are used in papers, but actually they are actually not that ideal for presentation. If I were you next time, I will just say no nest. Because if there's no nest, there's no egg. You can also say no nest, no egg. And then you say baby tracks, OFT. You say baby tracks. It's easier to remember. And then nest, no egg. And nest and egg. It's easier than these abbreviations for us to remember. So you see that if you make an abbreviation table yourself, you can give it color and highlight it. And again, if I were you, I would use some smaller icon of these plastics here. Sorry. Okay, this figure is large. It's nice. And then later during your discussion, you talk about, okay, this table I know is from the paper, but there are ways to make them more interesting. For example, if you just give this table, it actually gives no impression. But you can probably find some photos showing these effects of plastic on sea turtle. You Google some images, sea turtle plastic. You probably can find some image, especially entanglement. I'm sure you can find quite some image. It will give stronger impression if you want to emphasize the effects of plastics. All right, and then here you talk about the current system, but did you show the current system in your talk? No? So if you want to discuss it, you should at least use the space here and then show a map showing the current system. Otherwise, this statement is a little bit like out of nowhere. And then here you say it's your conclusion. However, these, to me, they are actually not really like conclusion, because conclusions should be iterations of your main finding. And these do not look like main finding. The main finding is you found more plastic in the turtle track without nest, without egg, right? So you think these plastic might have influenced the crawling behavior of the turtles. That's your main finding. And these are a little bit like interpretation, especially this one. Like one of the questions, you did not actually quantify microplastic. So this is actually not in your data. So this kind of conclusion should be avoided because it's not conclusion. It's interpretation. So you can put this discussion and then add a new slide because you don't have 10 minutes. You can add a new slide showing what's your main results, the main conclusion. All right? Okay, let's thank Vincent Liang.